All right, welcome back. So this video is to talk about tangent lines. So basically almost all of the worksheets and activities we've been doing, there's been something about tangent lines, and some people got to them and not everybody got to them. So I wanted to make a video for those that you never quite got to those problems ever in class and you would be stuck. Like if you had me to talk to, then you could figure it out. But without me, you'd be stuck. So this video is sort of supposed to help you figure out how to deal with tangent lines. So just a quick reminder about tangent lines and how they fit in with what we're doing today, or what we're doing with calculus here. So tangent line is a line that sort of acts the same way as a function does at a point. So like this point here, it has sort of a slope to it. You can sort of, if you zoomed in really closely to that point, you could sort of see what sort of slope it is. And it looks like it's sort of got this slope going on with it. So right here is the tangent line. And so to write the equation of the tangent line, well, we need to know two things. We need to know what is the slope of the tangent line. Well, that's exactly what we use derivatives for. So the slope of the tangent line will be the derivative. And then we need to know a point as well. And that's good because that is the point of tangency, basically where the curve and the tangent line intersect. We'll know that point as well. And so once we know those two things, so if we call this if we call this m and we call this h comma k, then we could write the equation of the tangent line using point slope form or transformation form. This is just a transformation. So yeah, so that's something we can do here, and that's why it makes sense that we're finding tangent lines in this calculus class here and using derivatives. So let's take a look at a specific problem that we'll deal with here. So these are some of the more basic sort of ideas. So the first one, we're going to deal with this function, big F of x is that thing there. And so for our first problem, we're going to find an equation for the tangent line to f at x equals 1. Okay. So if I come back up here and think about this, I need to find the slope and I need to find a point. So let's find the slope first, which means we're going to find the derivative and evaluate it at 1. So f prime of x is equal to, that'll be 4x cubed minus 12x. Okay, and so now we're going to plug in 1 to find the specific slope. So this is just a formula that represents all the different slopes for the different x values. We want an actual number. So f prime of 1, when we plug in 1, we are going to get, what does this end up being here? 4 minus 12, that's negative 8. Negative 8. So the slope of our tangent line is negative 8. Okay. The next thing we need to do is we need to find a point. So we've got the x value for our point. What we don't have is the y value. So let's find that by substituting in our x value into the original function, because we want the point on the function, not into the derivative. We're just going to get negative 8 again, and that's the slope. So minus 6 times 1 squared plus 4. So what does that give us here? 1 minus 6 plus 4. So negative 1, I think. Cool. All right, and so now we can write our tangent equation here. So it'll be y plus 1, so since it's a negative 1, is equal to the slope times the quantity x minus 1. And there you have it. There is our slope. You could solve for y if you wanted to, but you don't have to. And of course, if you make an error in there, that could cost you. So we just leave it like that. All right, so that's the most basic sort of tangent problem. Another basic one that we'll see a lot is sort of finding points based off of tangents. So same function, we want to find all the points on F where the tangent line is horizontal. Okay. So first off, let's find the derivative. We already found it. I'm just going to rewrite it again. I'm not like literally refining it again. And so now I'm going to do some decoding. If the tangent line is horizontal, I know the slope of it is 0. So in other words, we're interested in when is f prime equal to 0. Cool. So let's go ahead and solve this thing. So first thing I noticed is that they have a 4x in common that I can factor out. So when I do that, I get this expression. All right, so one of those things has to be 0, so either 4x is 0, which means x is 0, so I found one input so far. And then over here, x squared minus 3 is 0. When I solve that, I'm going to get positive and negative square root of 3. Cool. All right, so now we need to find the points. So these are the x values. It wants us to find all the points, so we got to plug in. Okay, so let's do it. We're going to find, first off, f of 0. So that's going to be 0 to the 4th minus 6 times 0 squared plus 4, so that's 4 is our value. Okay, so the point 0, 4 is one place. Great. Next, we're going to substitute in the square root of 3. So the square root of 3 to the 4th minus 6 times the square root of 3 squared plus 4. Okay, this one's going to take a little bit more thought process here. So let me knock down the ones that are a little bit simpler. So squaring the square roots, so we're going to get 6 times 3. And then here, that's the square root of 3 times the square root of 3 times the square root of 3 times the square root of 3. So when you have that, you'll have, I'll write it off to the side here, just really quickly. So the square root of 3 times the square root of 3 times the square root of 3 times the square root of 3. So that's going to be 3 times 3. So it's just 9 is our answer here. Sweet. And so what do we get when we do this? 9 minus 18, that'll be negative 9, plus 4 is negative 5. Great. And then now we'll do the same thing for the negative square root of 3. Note that when you substitute it in, since these are even powers, those will become positive. So as it turns out, this will also be negative 5. You could do like the real legwork if you wanted to, but it's this is an even function here. So that would mean that opposite inputs have the same output. All right, I think we're ready to report our final answers. So there are 3 points where the tangent line is horizontal. We're at the point 0, 4, and the point square root of 3, negative 5, and the point negative square root of 3, negative 5. Great, and there you have it. So those are 2 of the more basic types of tangent line equations. You'll see in your practice there can be more interesting ones where like drawing diagrams might be more helpful. But I just want to give you sort of a tool you can use and look back on if you ever have trouble with tangent lines. Thank you.